Hello everyone, this is Dr. Yaseen from Abhidanandar Senior College, Department of Chemistry, Pune, Maharashtra, India. Today, I am going to thank very first the organizers of the International E-Conference, the Food and Agroforestry 2021. Here, today I am going to talk about the influence of packaging and food waste management in the development of food processing. So how it going to be and how it's act as the a very important factor into our life. So processing of the food was an evolutionary instinct that was produced by the ancestors of a social animal and is based on uncountable trial and error experiments that have no definite record. The idea of cooking was uprooted with the discovery of fire in the Paleolithic era. So, and it should to be the foundation stone of the food production in human society. The eating habits of the human race mainly concern with the geographical area, and after accordingly the food processing evolved and the use of ice, sun, salt in food processing was understood by man, and various preservation techniques were also invented. So here I am going to give you the very key rule about the food processing is a link to the protection of consumption and the preservation of the shelf life of food for it to be eaten with the same nutritional value even after a long time. The Appert stated the first phase in modern food processing in 1810, where he invented the thermal in container processing in half a century before Louis Pasteur discovered the existence of the microorganisms. This uncountable experiments and the procedures were carried out in the same manner. We can have traditionally making a food last longer until spoiling is the most powerful motive for the food processing. So here we are going to for a better and the environmentally sustainable methods for a food production. Organic farming was recommended in the end of the 20th century. And the development of a food technology is defined in four distinct cycles of knowledge, starting from the zero stage in food sciences, which took place between right around about 1800 to 1950. According to the literature, where the challenge was to ensure the food integrity and the stability, that is you can say the shelf life and the protection, the microbiological control. Then between the 1950s and 1980s, this was the second and the first stage cycles were connected to the production of food products with the flavor enhancement. Then it came the third and the very important, which concentrated on the well begin between the 1980s and 2000s. But the new, that is the fourth stage, goes a further focus being in the various processes are there. So I would like to give you the different food processing unit and divide it into the primary food processing, the secondary food processing, and the tertiary food processing. So I can have the very primary food processing unit, which can be the agricultural products such as you can say raw wheat kernels or rice stalks are processed into something that can ultimately be consumed. And this processing, I can say, and it consists of the process such as drying, threshing, winnowing, grain milling, nutshelling, butchering the animals for meat processing, and so on are the products in this group. So can be categorized in the primary food processing. In the secondary food processing, I would like to introduce the produce the food in the process by using the ingredients that are ready to use. The bread making is an example of the secondary food processing. As you can know, whether it is packed at home, in a small bakery or large factory, the typical secondary food processing technique is the fermentation of fruits. Yes, it is the fermentation of fruits. You can have fishes and many more things we can do in secondary process. For the manufacture of beer, you can say wine and the other alcoholic beverages. It is in the second food processing we can have, secondary food processing. Now we can say the tertiary food processing unit. So this is the process that is the commercial production of processed food, the food items prepared but ready to eat, or we can say just eat and serve. The example like noodles, you can have noodles or meals served on an airplane. You can have this is the tertiary food processing unit. So I can have the importance of the packaging in the food processing as we can discuss about the primary, secondary, tertiary, and so on. So here it is the important, why it is so important. So I can give you the packaging and integral aspect of the food chain, that allowing the proper storage and the distribution of agriculture items from the plant point of the manufacturing to the end consumer, and new and refined food items, we can say. The packaging of technologies deliver new possibilities to reduce losses, maintain consistency, and add value to and retain the value. Addition of the value is very important, and the retention of the value is a very, very important aspect into this important of the food processing period. Now extending to the shelf life of agricultural products, we can have thereby the safeguarding is very important to the food supply. You can have the goal of this analysis seeks to demonstrate the importance of the packaging to the food industry, while ensuring the integrity of the food system. You can have the food loss. Yes, it is the food loss. You can have and waste prevention. It is very, very important about the prevention of the waste, you can say. On the background of the packaging in food processing industry, we can have what is the base and background behind all of the stuffs you can have. So I can tell you the maintaining the quality of the food and improving the protection and the decreasing waste from the post-harvest losses as a primary priority of a food infrastructure that is the sustainable and very, very strong development of the background of the food processes. There is strong post-harvest and occurrence losses and waste represents a big concern in the food industry. You can have, we can say, the various factors is the backbone of the food industries as well. So I think I'm going to as the time is not permitting me, so I will moving faster. I'm coming to the types of packaging materials and formats used in the food industry. In the fresh and processed food industry, a broad variety of packaging materials and the packaging formats are used to treat, store, and sell fresh and processed food products. See, from farms to customers. Yes, it's a relation between the two farms and the customers. So here you can have the different types of products are used to produce packages such as a glass, plastic, metal, cardboards, and the material used to depends upon the quality of the food product. We can have the different packaging units, and the materials have a variety of performance properties that have a direct effect of the shelf life. Here you can have the packaging for the liquid food items. You can have the bottles and the glass jars are mostly used, while solid food products are often wrapped in the plastics, you can say, and the cardboard. Yes, this is a very important factor. The processed fruit and the vegetables are generally packed in airtight metal containers to avoid the movement of the oxygen that could contribute to the food being run by the microbial growth, and you can have the lipid oxidation processes. Now, the most important consumer packaging is made up of a paper and a board. That's almost, having the 38 to 40% you can have. according to the World Packaging Organization, which can be in 2008, followed by the plastic, which is approximately 30 to 31%, with the rigid of plastics alone accounting for the almost 80%, and metal in the 90%. So glass 8% and the other are 5%. In the comparison, over the 70% of the total consumer packaging is used in the food industry, where 48% of the packaging is made up of paperboard. So here it is a very, very important fact. So here we are. We have to start with the new types of packaging materials, as the key point of the packaging materials are there. So it could be a paper, and the paperboard are sheet materials that produce from an interplaced network of the cellulose fibers and from the wood by using the sulfate and sulfide. And it has been the second most important is craft paper, as seen in your background. It is made by using the process that involves the pulverizing the wood pulp and the blending the material into the large sheet, strong brown and wood filaments, and it is the inexpensive option when it comes to the paper products. And one of the most common uses of the plain brown craft paper is in the manufacture of the paper bags for use in the grocery stores. So next is the sulfide paper, which can be used for the lighter and the weaker than the craft paper. It is the in the production of the process of sulfide paper, the wood pulp is treated with the peroxide or the hypochlorite, which can be subjected to the operation that yields the thick paper products. As it is used to make the small bags and the wrappers for packaging the biscuits and the confectionery. Yes, it is the next is the greaseproof paper that can be the burger can act into this paper, known as the beating, in which the cellulose of fibers undergoes longer than the normal hydration period. That is the most important and the most favorite thing for the new generation era. In the breakup became the gelatinous. Here it is the paper used to wrap the snack foods, cookies, and candy bars, other oily foods, used at being replaced by the plastic films. It provides a surface that is the resistant to the oils but not to the wet agents. So here we can have the uses are there. You can see the parchment paper. You can have the parchment paper related with the sulfuric acid bath, and the acid modifies that the cellulose to make it smoother, and improvements to water and oil, which adds some water strength. It does not provide a good barrier to air and the moisture, so it can be the paper we can use here. Here it is the paperboard. So paperboard, all of you know well, it's a higher weight per unit area, and it's often made in the multiple layers, which commonly used to make the containers for shipping and these such as boxes. So here we can have the next this glass. We can have the glass production. You can see into the screen. The production of glass containers involves the heating of the mixtures that can have the sodium carbonate. The stabilizers are there. Alumina is there. Calcium carbonate is there, which can be act as the sodium carbonate and act as the melting agent, and will have the temperature until the materials that melt into the thick liquid to mass, which in the transferred of the molds, and have the many advantages, but some disadvantages are there. So it's brittle and heavy and non-degradable is there. So here we can have the next is plastic. You can see the plastics. Yes, plastic, everybody knows about the plastic. It's in the polymer chain, which grows the condensation properties, the reaction between the molecules, and the accompanied by the formation of the alcohol. Here we can have the thermoseeable packages making use of the plastics, which have which having the low melting points, and to develop the very flexible structures, that is having the wrappings and the having the different polymers, which can have the thermosetting polymers and the thermoplastic polymers. Here are the branches of the having the, we can have the example for the thermoplastic polymers, and we can have the example for the thermosetting polymers as well. So here we can have the types of plastics. We can have many of we know. Just we have the lack of time, so we will move forward. The polyvinyl chloride, polyphene, polyesters, polychloride, polyvinyl halide, polyvinylidene chloride, polystyrene, polyamide, and ethylene vinyl alcohol are there, and polyethylene and polyesters are the most common plastics are there. So polyphylenes and LDPE and the HDPE, these are the types of polymers. So we can have the fast we can go. It's harder, the factors of the polypropylenes are there. It's harder and denser and the more transparent than the polythene. Popular use include yoga hut containers and the margarine tubes. So polyesters are the which are obtained by the condensation of the polymerization from ester monomers that results from the this kind of reaction, the polyethylene terephthalate and the polycarbonate as well. The most commonly used polyester in the food packaging is PET. You can have the next. So polyethylene terephthalate is very important synthesized by the condensation, as we have said. The tetraphthalic terephthalic acid, ethylene glycol, we can have the ample of advantage of this. Almost it's unbreakable, good barrier for gases, oxygen and carbon dioxide and moisture. The food products stored in the PET have the long shelf life as a good resistance to heat. Mineral oils, solvent and the acids, but not to the bases as well. So it is the main reason for its popularity, we can say. So here we can have the polycarbonate, which can form by the polymerization of the sodium salt of bisphenol acid with carbonyl chloride. We can have phosphogenes. Gene, you can say like this. It is a gas carrier properties are moderate but it provides the very good barrier against the flavors and the aromas, you can say. In PZ resistant to a wide range of this. We can have the we can show this one. We can rise a wide range of the temperature. I can say the melting point, which is 230 degrees Celsius. So we can move for a polyethylene naphthalene, which can be it's more but expensive than PET. It's very expensive, but it shows the excellent barrier properties as for carbon dioxide and the oxygen for water vapor compared those to the PET. But it is a condensation, again it's a condensation of the polymer, and we can have the dimethyl naphthalene as dicarboxylate and ethylene glycol. So next we can have the polyvinyl chloride, which can have the good flow characteristics and the stable electrical properties, which obtained by radical polymerization and chain polymerization from vinyl chloride monomer. So it is the heavy, stiff and ductile. So we can have the next year's polyvinyl polyvinyl chloride is PVDC, we can say, and it's a heat accessible and serves as an excellent barrier to the water vapors, gases and fatty and oil products, you can say, into the structures. So polystyrene, you can say it is the most typical application of the polystyrene. It include the protective packaging such as egg cartons, we can see here, containers, disposable plastic as well, and the silver scale, lipids, cups, lids, cups, plates, bottles and food trays as well. So it is the main fundamental application of this. Polyamide nylon is the, yes, we can have the nylon, the polyamide within an amide structure, which in its main chain CO and H. The polyamide is synthesized by condensation, again reaction between the diamine and the diacids, where the repeating units are held together by amide, which can links. It's a low gas permeability and it's a good chemical resistance, which can give you the toughness, yes. So ethylene vinyl alcohol is the next. We can have the greatly affected by the humidity, and it's therefore mostly used in the multi-layer and extracted films situation where it is not in the correct contact with the liquids, we can have, and it's an excellent barrier of oil. So metals, yes, the next is metals are the most versatile of all forms of packaging. It's a decomposition of the nutrients is kept to minimum metal containers, since metals are perfect barrier to the oxygen and the light and moisture. It's difficult to crush, so that the major limitation of the metal containers are cost and the weight of the containers are very difficult to crush. And the aluminum and the steel are the most predominantly used metals in the food packaging. You can see here, the number of aluminum foils and sheets are there. You can have the where it exists in the combination with the oxygen as a alumina. So it derived from the bauxite ore, and where you can have the highly resistant to most forms of the corrosions. Its natural coating of the aluminum oxide provides a highly effective barrier to the effects of air temperature, and you can see the moisture as the chemical attack. So here it is the suitability for the food contact enables a wide range of the application in many different products and sectors as well. So here we can have the slight material, the strong can be formed and converted to complex, and aluminum foil is used for an aseptic cartons and pouches, wrappings, bottle capsules, and many more, and the lid trays and all. These can have the tin plate. You can see it is used for the preserving the food for well over the 100 years. You can have the tin plate is the result of coating both sides of black plate with the thin layers of tin. We can have the coating is achieved by the dipping in the sheets of the still in the molten in the that you can have the hot dip tin plate by, or it can have the electro deposition of the tin on the still. You can have the electrolytic tin plate. This is the very effective through the oxidation of the tin surface in preference to the oxidative degradation of the food. You can have the tin free steel. You can have the oil flame, chromium oxide, metallic chromium, and base steel. You can see the requires of the coating and organic material to provide the complete corrosion resistant, and it has the good formability and something, but it is much cheaper than the tin plate. You can have it's and now you can have the different packaging methods. You can see the aseptic packaging. We can have you can see the food products such as the ultra high temperature. You can see milk, and its packaging is sterilized separately, then combined still under the sterilized atmosphere. You can have it's increased the life of the shelf. You can see into the figure. We can have the applicate naturals, that is the vacuum packaging. It's procedure in which air and drawn out the package prior to the sealing, but no other gases are introduced. Here it can have the many years for the products such as cured meats and cheese, which is following these techniques very importantly. So third and the very important type is modified atmosphere packaging. Here we can see its procedure, which involves the replacing air inside a package with the predetermined mixture of gases prior to the sealing on it. So we can have the same, and the modified atmosphere packaging is here. It is the nitrogen has no direct effect. Oxygen is having the included the MAP packages of the red meat, and the carbon dioxide reacts with the water into the product to form the carbonic acid, which lowers the pH of the food, and it also inhibits the growth of the certain microorganisms, mainly molds and the aerobic bacteria, which helps to the oxygen. And here which can have the oxygen as well, which is due to the oxygenation of the myoglobin pigments as well. So you can have some novel packaging methods I have introduced over here into it. The present the biodegradable packaging, as we can see the definition of the biodegradable plastics, which is degradable plastic in which the results from the action of naturally occurring organisms such as bacteria, fungi, and algae. You can have the most important definition in this way. So here you can have also the bio-based polymers or biopolymers are obtained from the renewable resources. We can have this requirements include the barrier properties such as the water vapor gases, lights and the aromas, optical properties. You can have the migration resistance, chemical and the temperature resistant as well, the ability to satisfy the disposal requirements, to retain the sensory properties as well. So here we can have the polymers such as the polylactite, that you can have PLA, which composed of the carbon dioxide. They can have the recycled and the composted, and their physical and mechanical properties can be tailored by through the architecture of the polymer. You can see here you can have the active packaging. Very important aspects of the active packaging is what the innovative concept that can be defined is mode of packaging in which a package, the product and the environment interact to prolong the shelf life or enhance the safety or sensory properties such as the quality of the product to maintain the same, and according to their functionality as the scavengers, the regulators and the emitters, and their action can be specified for the several substances like oxygen, the carbon dioxide, and as well as the ethylene as well. We can have the internal atmosphere by regulated the substance that absorb, we can have to release the gases or the vapors as well. The oxygen scavengers are the oxygen can be help to maintain the food product quality by decreasing the food metabolism, reducing the oxidative rancidity, inhibiting the undesirable oxidation, label the pigments and the vitamins, controlling the discoloration of the enzymatic properties as well, the growth of the aerobic microorganisms, as a small sachet containing the various iron-based powders as the assortment of the catalyst. So where we can have the different packages. You can see into the figures right now. You can have the reactive hydrated metallic reducing agent that scramble the oxygen within the food as well. So here we can have the ample of the advantage of the scavengers is that they are capable of reducing the oxygen level to the almost 0.01% into the act of the non-metallic scavengers include those that use organic reducing agents such as the ascorbic acid and so on. So here we can have the next the carbon dioxide scavengers. Same function is having you can have the coffees having the hermetically sealed in packs directly after roasting. The carbon dioxide release builds up within the packs, eventually causes them to burst. The use of carbon dioxide scavengers is particularly applicable for the fresh roasted or ground coffees to produce the significant productions as well. So here we can have the different dual action sachets and all. We can have the number of the ethylene scavengers as well. We can have the we can move to the, as time is not permitting me, as I'm not taking much of it, I will skipping my such of important topics. I will come to the edible packaging right now. The is defines a thin layer edible material formed on a food as coating or placed the between the food components as well. The natural polymers have been studied extensively for the development of the edible packaging, which can be produced, and the mixtures to produce the edible films, which can have the polysaccharides, we have starch, we can have the hydrocolloids as well as the proteins. So we can have the lipids as well. So you can use, so edible films and coatings have some advantages such as edibility, biocompatibility and barrier properties as well. It has been considered to be very active packaging as well. So here we can have the intelligent or smart packaging. So it is the very important essential factor. We can I will really want to focus on it. The smart packaging is basically designed to monitor and communicate the information regarding of the food quality. In addition to this, is self-heating and the self-cooling containers with the electronic displays indicating the buy dates and the information regarding the nutrition qualities and origin of the product. We can have the mechanical and chemical and as well as the electrical driven functions that enhance the usability of the effectiveness of the food product in product. So here we can have the smart devices which can be incorporated into the packaging materials, are attached inside or outside the packages as well. So here we can have the FDA recognize the products or the importance may increase into the seafood industry as well. So here we can have the next very important nano packaging. So nano scales innovation could be potential to introduce the many amazing improvements like have the food packaging in the form of barrier or mechanical properties, detection of the pathogens and the smart active packaging as well into the food safety and the quality of the benefits. So by adding the nanoparticles, one can achieve the packages with a more resistance to the light and fire, better mechanical and thermal performances and less gas absorption as well. With the different nanostructures, the plastic can be given various gas and water vapor levels to fit in the requirements of various foods. So here you can have the addition to the nano sensor to food packages could be used to detect the chemicals, pathogens and the toxins in the food as well. So here we can have the different methods of the packaging as well. So here we can have the final and the last segment of my topic, that is the management of the food waste. The food waste is the primarily but not necessarily present at the final customer stage of the food supply chain, that is at the level of the household. During the production, delivery, retail, final consumption and the post-consumption process, the food loss is produced. During the harvest operations, example, the threshing of the fruit harvesting, or you can have the crop sorting. The food losses at the first level are typically due to the mechanical damage or can have spillage. The key causes of these food losses are the environmental influences like temperature and the weather conditions and economic consideration as well. So here it is the food losses at the post-harvest, handling, shipping, refining and the delivery stages are known to be any reduction in edible food mass that has been accidentally spoiled or spilled or lost, you can say. For example, you can have the food losses occur due to the spillage or deterioration, lack of storage facilities, transport between the farm and the delivery at the post-harvest handling point, and a significant amount of food waste occurs during the storage due to the rodents and the microorganisms. The food loss too is due to the spillage or deterioration. That is, you can have the example of the juice production and the canning during the agricultural manufacturing. Food waste can also be produced at this stage during the washing, peeling, can have slicing, boiling, interruption of the processor by sorting out of crops. Due to the lack of adequate transport methods, inadequate packaging, time restrictions and supplier buyer relationships, along with the poor infrastructure, food waste is produced at the distribution level, as its loss is generally referred to as food waste at the retailer level, as it's created primarily due to the deliberate decisions to discharge the food. The second important strategies we can have for the management and the valorization is the key techniques for minimization and valorization are such as the incineration, anaerobic fermentation, composting, a landfill, or you can have the use of cross residues for the agriculture purposes such as animal feed or fertilizers. The management approaches the therapies which can have the recycling, reuse, proactive constituents from food waste have created more concern on the recycling between the past few years. There are primarily pectin, flavonoids, we can have the carotenoids and silk and polyphenols in citrus byproducts as well. The massive volumes of the water waste from the olive oil are significant processing for the concerned land water ecosystem may be an alternative sources of the biologically active polyphenols. The byproducts of the meat production may alternative sources promisingly usable integrants such as the proteins to recover as well. There are the number of treatment of food as we can mention over here, the valorization of the nutrition of livestock, the landfilling practices, and we can have the different parameters for this. So I can explain you for the having the valorization, the nutrition of the livestock. Here we can have the food production waste as animal feed. We can have the physical as well as the chemical, thermal and biological methods with the many advantages and the drawbacks as well for the food industry waste. We can have the it's while substrates the high in cellulose and the hemicellulose may be sustainable for feeding the ruminants. The second most important practices we can have the landfilling practices of the disposal of solid waste for many cities, since it is one of the cheapest choices with management classified the waste disposal. You can have the compression and the storage filling at the suitable location, and it's having the different 4 stages, and that stages will be aerobic degradation, hydrolysis, fermentation, acetogenesis and methanogenesis. So what are the with the have the definition? I can give you the brief idea about the aerobic the biodegradation. Let's have the hydrolysis. We can have the many organic contaminants are the rapidly degraded and the aerobic conditions in the bacteria called as the aerobes. You can have the this basic fermentation and the acetogenesis process. What is a fermentation? Is a metabolic process. You can have the products which can be chemically changes its organic substance through the action of enzymes in the biochemistry as well. So we can have the acetogenesis process through the which acetate can produce the either the reduction the carbon dioxide or the reduction of the organic acid as well. And the methanogenesis is the formation of the methane by microbes known as methanogenesis. So here we have the third strategies, the biofuel convergence methods. There are the high number of organic compounds in the food processing waste that could be converted into energy, and energy will be and then recycled in the form of heat and electricity. The key methods for this is the anaerobic digestion and the biofuel convergence are the thermochemically, oxidation, gasification and the pyrolysis therapies as well. The microorganisms are used during the process to preserve the food waste in the absence of oxygen. The chemical substrates are degraded, and since it contains the ammonia, phosphorus, and the n number of the minerals which can be slurry may be used for the fertilizers as well. At the same time, we can have the generation of the biogas as well, the combination for the methane as well as the traces of the water, hydrogen sulfide, or the hydrogen is the later biogas to produce the electricity through the thermal energy and used to minimize the fossil energy consumption as well for the carbon dioxide emissions. So number 4 is the composting and the vermicomposting. We can have the organic materials by the production which can be composed with the aerobic deterioration, and some of the organisms such as fungi, bacteria, protozoa in comparatively stable products. We can have the vermicomposting is the mechanism by which the earthworms transfer organic materials into the humus-like substance. Fertilizers are produced by both the methods, which can have the compositing produces the biomass as well as the capable of the enhancing the soil structural properties, ranging between the raising its water ability and increasing its what you can say the nutrition sustaining and the living soil species as well, and eventually helping to restore the organic materials to the soil as well. The essential condition for the maximizing the biological activity for the temperature, the pH, and carbon and nitrogen ratio, which can have the having the oxygen and the moisture content. So here we can have the all three stuffs of my talk, and basically finally I'm come to conclusion. I'm very much happy to conclude my talk, like the various challenges we can have facing for the food production, and the even we can test it the process need to constant assessment, design, and the evolution. With growth, food processing has become the easier for the customers and the trustworthy industry. The food processing industry was improvised over the time by safer methods of planning, manufacturing, and the advanced food waste management. Although many processes are old, but still we can have this standing in the advanced technological world, making in the industry's base a solid and the holding customer demand field from the time to time. Food processing is an endless process. Yes, people travel quicker and need to be handled quickly because everyone has a time limits. For customers, we can have for customers we can have the advanced and the smart packaging as very beneficial, as there is clarity between the seller and the buyer. There's no option to trick the customer as well. The advanced method of the food waste management often allows using the food for the other purposes as well as even if it is not useful for the consumption. I think it would be possible to solve the demand for the enormous the population of the world with the more development with time. I am very much happy, and I'm very much thankful to the organizers and the to giving me an opportunity to to present in front of you the dignitaries on the dice and the off the dice as well, and on the you can say on the e-learning activity. So we can have the international conference for an opportunity. I'm very much thankful to again I'm thankful to my co-workers, my partner, my research students as well. I'm thankful to them also to organize such a wonderful presentation in front of you. I'm thankful to Dr. Habib Patan sir and the chairperson to giving me such a beautiful opportunity. So the session is open for the question and answer. Thank you so much.